Last week on Friday, we learned about the double hashing, and you understand how we can use the first hashing and the secondary hashing, or the first function and the second function. And as you know, there will be the performance issue. What is the performance? In the case of the hashing, in the worst case, search, insertion, removals on a hash table take O(n) time. So if you have n, the data size is n, then the worst case will take O(n). The worst case occurs when all the keys inserted into the map collide. It means if there will be a lot of collision. Okay? So if there are a lot of collision, then it means we will have O(n). And there is one factor, we call it a load factor. The load factor, we use the alpha. The alpha means it is small n divided by big N, and it affects the performance of a hash table. So as we know, the n, if we have like the array size, and then the big N, the big N is the array size. We usually use the mod big N, and then the N is the number of data that we use. So the alpha is small n divided by big N. If you still remember, using this N, this big N. This big N means this is the size of the array, and this must be prime. So if we have small n, which is the number of data divided by big N, we can have alpha. So assuming that the hash values are like random numbers, it can be shown that the expected number of probes for an insertion with opening address is something like this one. So we can define the load factor. Let's say we have the n is 25, and then the big N is 13. Then we can have this one as the alpha. So the alpha is greater than 1. Okay. So if the alpha is greater than 1, so 1 minus something bigger than 1, then this will be higher than 1. So we call that one is the load factor for the hash. The expected running time of all the dictionary ADT operation in hash table is O(1). Okay, so this is the expected, because we want to make the performance very quick. Okay? But it depends on the load factor, and it depends on the number of data, and also depends on the number of array that you provide. In practice, hashing is very fast, provided the load factor is not close to 100%. So if it is close to 100%, so it means like close to 1, then 1 minus 1 is 0. Of course, it is not appropriate for 1 divided by any number. Let's say 1 divided by 0. So it will not be possible. The application of hash tables, we can usually use the small database. In the small database, it is good for applying the hash tables. Compilers, when we are running Python, or when we are running Java, we can use compiler. So that kind of things we use hashing. And browser cache. Browser cache means if you browsing with Chrome or Internet Explorer, there will be a kind of browser cache storage. So we got it. This is browser cache. It is to save what is the link that you visited. Okay, that's what we can learn from here. In the e-class, I give you another materials. Yeah. So in the week 9, in the priority queue map handles table, I give you one example about the dictionary. So we already checked the code of the priority queue. Now let me explain a little bit about dictionary. As you know, in the Python, we have the built-in map dictionary, or we call it this is built-in map. In the case of the built-in map, we can just use dictionary in Python. And let's suppose I want to create a dictionary. So you already know this is a dictionary because we have key and value. Key and value. Key, value. Key, value. Key, value. So what is this problem? I want to make squares. Squares. So 1 squares. So it is 1. What about 2 squares? 2 power of 2, then it is 4. 3 power of 2, it is 9. 4 power of 2, 16. 5 power of 2, 25. So we call this is squares. Okay. Now I want to limit until just 5. Okay. And I think you already learned all the functions in the map. Okay. In the basic function of map, we have pop. It means I want to remove. If I want to remove 4, the key equals to 4, which is this one. I want to remove it. And if I print again, there will be only 1, 2, 3, and 5 because 4 has been removed. And let's say I want to remove any item. Okay, pop item. If you still remember, the pop item means we want to remove random values from dictionary. Then, yeah, suppose, yeah, I guess if you check on this line, yeah, it depends. So you can check later what is the item that will be removed. Let's suppose the item that will be removed is 5. Okay. I already run previously, so the item that had been removed is 5, 25. So we will show the output because we are going to print. And then you will print again, let's say squares. Yeah, if you have these items, we have 1, 2, and 3. And then if you want to remove all items, you can just make a method. You can just call a method clear. And then if you want to print squares, there will be empty because every of the item has been cleared, or we have no items. And at the end, if we want to delete, then you will have an error. So if you run, there is an error. Why? Because at the end of this statement, we delete the variable squares. and then there will be an error with this error message. Name squares is not defined because it has been deleted. Now I want to teach you something more, maybe not advanced, but it is a little bit complex code. Now I have a dictionary comprehension. I want to create a dictionary, but making the dictionary is using a function. So I want to make X. Okay. And what is X? X here is any variable from 0 until 6. Okay. And because it is the range of 6, so it will not until 6, but it is until 6 minus 1. So it will be until 5. And for every of the value, I want to do X multiply by X. It means I will do square. So the result of this one will be 0, 0, 1, 1, 2, 4, 3, 9, 4, 6, 5, 25. Okay. It starts from 0 until 5. We call this is the dictionary comprehension. So you can put all the functions, for loop, everything inside the dictionary. Or you can have another kind of way to define the squares. Maybe you know this mechanism. First, I want to create a dictionary with blank, and then I will do for loop. I do from 0 until 6 minus 1. And then for every of the squares, I will define X. X is the key. And then the value will be X multiplied by X. So you can insert a value into the dictionary. And the result will be like this one. So this one is the same with this one. So in Python, as we learned in the first part, we can have the comprehension syntax, or the syntax is inside. Let's say this is dictionary, then it is inside the curly bracket. If you are using list, then it is inside the list. And you can also make a kind of conditional. Let's say I want to just do the squares on the odd value. On the odd value means if it is 2, 4, 6, 8, I do not want to include them into the dictionary. Then I can do something like this. Now I'm making the range is a little bit higher until 11. The idea is still the same. X, it will be the X multiplied by X. And then for X in the range of 0 until 10, now you can see there is a condition. If X modulo 2 equal 1, then if the value of X cannot be divided by 2, then it is odd number. And you can put them into the X. So the result will be 1 as the key and then 1 as the value. 3 as the key and 9 as the value. 5 key and 25 is the value. So this is only the odd numbers. And you use the comprehension syntax to create this value. And you can do something like what you already learned in the first part of our course. if you have the squares like 1, 3, 5, 7, 9, like this one, and then you want to check whether 1 is in the squares, or 2 is not in the squares, or 49 is in the squares, what happened? You can check the key. 1 is in the squares, yes. 2 not in squares, yes, because there is no 2 here. 49 in squares, the result is false. But look, there is 49. Why Python give false? Because when you do like this test, it means it is only the key. Okay. Membership test for key only, not value. Okay. And if I want to do iteration, so let's say I have the squares 1, 3, 5, 7, and 9, and then I want to check for every of the values. Then you can do for loop for I in squares, and then you can print the squares based on the value, based on the keys. So if it is 1, then I will print the values. If it is next element, I will print the value, which is 9. If it is the next element, I will print the value. Yeah, there are still many things in the dictionary, but I think it is enough for you to understand how to put in the dictionary. I also put the kind of review. So for you who have difficulties to understand my explanation about the hash table, so I give you the example about this one. So the idea of separate chaining. What is separate chaining? Let's suppose I have all these values, okay? And then I want to put all this value into this, I call this is an array, and then I want to use the hash table. And we know that we will do the hash function with mode. Okay? Mode means the remainder value, and we know that this has n equals to the big N equals to 13. So if I have 54, then I will do mod 13. 54 mod 13 equals to 2. So I will put into the index 2. What about 18? 18 mod 13 equals to 5. Then I will put into the index 5. 28. 28 mod 13, it is 2. Because I already have 2. But no problem. We are going to create a chain. That's what the meaning by the separate chaining. 36 mod 13 is 10. 35 mod 13 is 12 here. 41 mod 13 is 2. Okay, then I will create a new element here. So this is another, this is what we call as the separate chaining. And so on. The 13 mod 13, the 38 mod 13 is 12. 10 mod 13 is 10. So we have another chain. We have another chain here. 12 mod 13 is 12. We have another chain. And 90 mod 13 is 12. So we have this chain. This is what we call as the separate chaining. So in one location or in one index, there will be another chain. There will be another chain. There will be another chain. So we call this is the separate chaining method. What about the linear probing? The same with the hash function that we learned before. We will use the mod 13. So mod 13, 18 mod 13 is 5. So we put into the index 5. And then I put the 41 in the index 2 because 41 mod 13 is 2. And then 22 mod 13 is 9. So I put the value 22 in the index 9. Now I have 44. 44 mod 13 is 5, but it is not separate chaining. We are going to use the linear probing. Then we will put the 44 into the next empty location. So the next empty location is 6. 59 is 7. 59 mod 13 is 7, so we just put in the 7. 32 mod 13 is 6, and we see that 6 has been filled with another value. So let's go 7. 7 is not empty. Then we go to the next, which is 8, and we put 32 in the 8. What about 31? Okay, 31 mod 13 is 5, but 5 has been filled the value. Then we go to the next. 6, okay, there is a value. 7, there is a value. 8, there is another value. 9, there is another value. So we put the 31 into the index 10, which is empty. And 73 mod 13 is 8. So we can put in the next, but 9 is not empty. So we go to 10, 10 is not empty. Then we go to the next, which is 11. In the double hashing, you also learn if we want to put the value into one location, but if the location has been filled, so we will use the second function. So we will always calculate the HK and DK. Yeah, the HK is the first function and DK is the secondary function. 18 mod 13 is 5, and we have the DK. The DK is 7 minus K mod 7. So 7, which is the constant value, minus K. K is the number 18 mod 7. 18 mod 7, it is 4. Then we have 7 minus 4, which is 3. This is for the secondary function. Because 5 is empty, we just put 18 into the index 5, or we call this is the 5 is proved. Again, 41 mod 13 is 2. The secondary function is 1. What about 2? 2 is empty. Then we can just put into the index 2. Not 2. This is actually should be 2. Right. Why I put 1? Sorry, this one should be 2. Okay, I will change later about this one. And then what about the 22? 22 mod 13 is 9. So we just put into the 9. And 44 mod 13 is 5. Oh, 5. We have the same with the 18. Then we can check the secondary function. But the secondary function is also 5. Then what we can do here is to put with j. J equals to 0. So we can have I, which is 5, plus 0 multiplied by 5. So it is 5. But if we put j equals to 1, so 5 plus 1 multiplied by 5, then the result will be 10. So Oh, okay. I put this one. And then don't forget that we have the mode 13. So we put the 44 into the variable index 10. And then we have 59. If 59 mode 13 is 7, because 7 is empty, so we put into the index 7. 32 mode 13 is 6, because there is no value in the index 6. We just put it into index 6. 31 mode 13 is 5. Okay. And then the secondary function is 4. Okay. I think this is not 4. Oh, yeah, this is 4. So we can have 5. This is I. And then J, if it is starting with 0, 5. If it is J is 0, then multiply by 4. 5 plus 0 is 5. And then J, if it is 1, then 5 plus 1 multiplied by 4 more 13. And the result is 9. But 9 has been filled with another value. So we will check with the J equals to 2. So when J equals to 2, then we have 5 plus 2 multiplied by 4 more 13. And the result is 0. And we put into the index 0. And 73 mode 13 is 8, because 8 is empty, then we put here. Okay, so I will, this should be here. Okay, that's about the HashTable. Hopefully you understand the concept and the examples. Now I'm going to continue into the new chapter, which is about graph. Yeah, some of the teams try to adopt the shortest path. Okay? And the idea of the shortest path is from graph. We will learn about the graph and the terminologies, and then we will learn about the graph ADT, and we will learn how to do the implementation with graph with some Python code. What is graph? A graph is a pair of V and E. What is V? V is a set of nodes. In some literatures, they call it nodes. In some literatures, they call it vertices. Vertices is the plural form of vertex. So vertex is singular, vertices is plural. So it means many. And if you can see from this node, what is node? Node is some kind of place, or it can be anything. For example, a node is a person, or a node is one document. In this example, a node is an airport. The O vertex represents an airport and stores the 3-letter airport code. So for example, SFO. The meaning of this SFO is the airport in San Francisco. E. E is a collection of pairs of vertices. pair of vertices. We call it edges. Vertices and edges are positions and stores elements. If you still remember the position, in the position, yeah, we use in the priority queue. Okay, we have the position class to create the key in the priority queue. If we have vertex as the airport, and what is the edge? The edge represent a flight route between two airports and store the mileage of the route. So for example, HNL. What is HNL? Oh, HNL is Honolulu. And then LAX. What is LAX? LAX is Los Angeles. Then I know from the Honolulu to Los Angeles, the mileage is about 2,555. From San Francisco to LAX or Los Angeles, it is about 337. So the X is a kind of pair. Honolulu, LAX. Then it is a pair of vertices. And then I have another which is SFO, LAX. So if this one, maybe I can say 255 is the mileage between HNL and LAX. And I have 337 is the distance between the San Francisco and LAX. Based on the definition, we can have directed edge. Directed. There is a direction there. It is an ordered pair of vertices U, V, and we can define the first vertex U is the origin, and the second vertex V is the destination. If you know a flight, we have flight from Seoul to Busan. We have a flight from Seoul to Jeju. Then let's say this is the flight from ORD to PVD. What is ORD to PVD? Now, we have a flight from OHR, is from Chicago to PVD, to Pennsylvania. So we have ORD to PVD because there is a link. And in this case, the flight number will be AA 1206, just example. We call this is directed edge. So if you see any arrow of this one, then you can say that this is the directed edge. Undirected edge. In the undirected edge, we don't have any direction. We don't have any arrow. It is unordered pair of vertices. So for example, a flight route. So I can say if it is from the OHR, Chicago to Pennsylvania, from Chicago to Pennsylvania, and from Pennsylvania to Chicago, the distance is the same. The only difference is maybe the flight number. We call directed graph if all the edges are directed. So if all directed edges, then it means we call this is the directed graph. For example, route network. So if you use the navigation I want to go from Mohyun to Seoul. So there might be many route networks. I can go to Gwangju, I can go to Bundang, then there will be a very complex network if I want to go from Mohyun to Seoul. And that can be one of the directed graph. If it is undirected graph, it means all the edges are undirected. You can see the flat network. Yeah, this one is one example of undirected graph. There are many applications we can use into the circuits, electronic circuits, printed circuit board, integrated circuits. Or if you are doing with the transportation networks, there are many networks like highway, flight, bus, train. Yeah, so those kind of networks are also using graph. Or computer networks, if you want to use like Wi-Fi or the internet connection, the local area network, internet, web, it is also using graph. Database, if you learn database, you can also see the relationship between entity, or we call entity relationship diagram. It is also one of the application of the graph. Okay, I guess I will stop now because I need more time to explain this terminology.